Hello, my name is Chris Mata, and my DSP mini project is about Gabor filters and camouflage. Lou Bolin is an artist who paints himself into the background of his photographs in an attempt to camouflage himself. Here are a couple of his photographs that show how he accomplishes this. The goal of this project is to use Gabor filters on Lou's photos in an attempt to pick him out from his backgrounds. A two-dimensional Gabor filter is nothing more complicated than a Gaussian modulated by a sinusoid. This is the equation for a 2D Gabor filter. As you can see, it is comprised of a Gaussian kernel multiplied by a sinusoid. Also, as you would expect, the frequency response is nothing more than two Gaussian pulses corresponding to the modulating sinusoid. Here is a Gabor function with a 30-pixel wavelength, 0-degree orientation, aspect ratio of 0.5, and a bandwidth of 1. The wavelength governs the width of the stripes in the function, and as we can see, decreasing the wavelength produces thinner stripes. The orientation governs the rotation of the Gabor envelope. This is the output for theta set to 45 degrees. The aspect ratio controls the height of the function. For a very large aspect ratio, the envelope approaches a height of 1 pixel, and for a very small aspect ratio, the height stretches across the image. The bandwidth controls the overall size of the Gabor envelope. For a large bandwidth, the envelope increases, allowing more stripes, and with a small bandwidth, the envelope tightens. This is the first image that I processed using Gabor filters. This image was selected because of its mostly regular background. The hope is that the Gabor filter will be able to pick out textures corresponding to Lou's body that aren't horizontal like the stripes in the background. I first processed the image with a rather large Gabor filter to determine the general location of vertical textures in the image. As you can see, the filtered image shows that there is an area containing vertical textures. The next step will be to combine more orientations so that we might find a more rigid outline of Lou's body. Combining 4 more orientations gives us a much better view of Lou's body with the background stripes completely eliminated. The second image I processed using Gabor filters was much more challenging, as you can see. The background is no longer one texture of horizontal stripes, but instead much busier with different textures throughout. A first attempt was made to use the same orientations that were used for the first image, but the results were much poorer this time around. This is due to the fact that Lou's body is not the only part of this image with vertical textures. A new strategy was needed in order to find Lou, so I presumed that wherever he might be, it will be probable that he did not paint the textures on himself as well as the background. I proceeded to find the orientations for the different sections of the background. The hope is that when all of these orientations are combined, there will be an area corresponding to Lou's body that is not as bright as the rest because he was not able to copy the background textures exactly. The strategy worked, and a dark human shape is able to be seen among the otherwise light spots. However, this might not be the easiest way to tell if Lou is camouflaged in the image. Thresholding was implemented, in which all pixels of intensity higher than a certain threshold were turned white, while the rest were turned black. The results of the thresholding show a large dark section corresponding to Lou's position in the image. The other dark areas correspond to the plain white sections of the shirts, as well as textures that were not accounted for. I was able to perform all of the filtering in this project thanks to a great website provided by the University of Groningen. The website is hosted by the university and provides an easy interface for MATLAB-implemented Gabor filtering. Thank you for watching my video, and I hope you learned a little bit about Gabor filters.